Hello all, welcome to Lesson 10. So we're going to be looking at categorical variables. So the scenario where you have two categorical variables and look at two-way tables. So starting off, categorical variables are variables that when we record them, they basically put each individual into a category. It could be, hey, what day of the week was a person born? It could be, what is your preference, red or blue? Like, all sorts of things like that. It could be a couple of categories. It could be many. So these values, they're labels. And we tend to describe their distributions as counts, percents, or proportions. So you might say the count in each group. Percents or proportions might be more useful if the counts are very, very different from one another. And then at least early on, so when we're just looking at one categorical variable, we can organize it in a one-way table. So this is the example of a one-way table. The question basically being asked is, what types of movies are currently playing? And so we have categories. We have 4 categories: comedy, action, horror, drama, as if anything, everything fits in there, and then counts. So 4 of the movies currently playing are comedy, 3 are action, 1 is horror, and 1 is drama. If you were to add all of them up, you have 10 movies. So 4 out of 10, that's 40% of the movies are comedy. 1 out of the 10, 10% are horror, and so on. So this is a one-way table because there's just one categorical variable being looked at. So when we have a data set that has 2 categorical variables, so there are 2 questions or 2 measurements recorded, then we start looking at counts or percents, typically for one particular variable at a time. So a two-way table, it describes 2 categorical variables, organizing counts according to a row variable and a column. So the columns are associated with the categories of one variable, and the rows are associated with the values of a different categorical variable. So this example that we're going to use, it looks like it's an older example. They looked at sex, male and female, very binary, to pet preference. So does the person say they prefer dogs? Do they say they prefer cats? Or do they say that they have no preference? So looking here, it looks like, 36 male individuals said they prefer dogs, and 22 female individuals said that they prefer dogs, and so on. So what are the categorical variables? So we have the categories sex as columns. We have the categories, the pet preference as rows. So sex and pet preference. And for me, I usually will try to write what the categories are. So here there's just the 2 categories for sex, and then for pet preference there were 3 categories: dogs, cats, no preference. So for marginal distributions, that tells us, hey, let's just focus on one of these categories. So it's the distribution of just one variable while totally ignoring the other one. So in order to investigate it, use the data in the two-way table, focus just on the rows or just on the columns. Decide ahead of time which, and then you can use a graph to display that marginal distribution. Okay, we're going to look at the marginal distributions, the marginal distribution of preference and the marginal distribution of sex for the example that we were looking at there. So if I'm looking at just preference, this is saying, okay, I'm going to look at the total number of people. So out of 100 people, how many of them prefer dogs? So I'm essentially looking at these totals here in that last column. So 58 individuals out of 100 prefer dogs. That's 58%. If I'm looking at preferring cats, that's 8 plus 26, that's 34. So 34 out of 100 prefer cats. That's 34%. And then no preference. We had 8 individuals that had no preference. So 8 out of 100. That's 8%. Note if I were to add those percentages back up, they would add up to 100%. Or at least they should. So now, if I want to go ahead and find the marginal distribution of sex for the marginal distribution for sex, I'm pretty much going to focus right here. So, watch, these got flip-flopped. I think I went in alphabetical order one of these times. So, there are 54 individuals out of 100 that are marked as female, so that's 54%. And there are 46 out of 100 that are male, so that's 46%. So if you added those two up, you'd get back to 100%. That's what you should get. And that's how we would calculate those. So it's pretty much saying, okay, well, let's count all of the individuals that prefer dogs out of the total. And the total here is there's 100 total people here. Just continue to do that for all parts. So if I want to look at the marginal distribution of preference, I need to borrow this. So 58, 34, 8. So 58%, 34%, 8%. I wanted to put this into a graph. This right here, this is a bar plot or bar chart. I know that because what goes on the bottom here are categories, and I could put them in any order I want. So right now, they're in alphabetical order. But you could put them in whatever order you want. You really could. You could put them in highest preference to lowest preference. You could put them in whatever order you like. So here's each category. So no preference, that's associated with 8%, so it's just under 10. Prefer cats is at 34. Prefer dogs is at 58. And you can see that they line up. And so if I wanted to describe this distribution, I could say, hey, no preference, has the smallest bar at about 8%. Prefer cats is kind of in the middle with a bar that's at 34. Prefer dogs has the highest bar. It's pretty much describing each bar and the relative height to the other bars. Similarly, we can do a marginal distribution for sex. So it's 54 and 46%. So this should be 54%. It lines up above 50, 46. It should line up a little above 45-ish. So yeah, this one, there's only 2 categories. So if they said, hey, describe the distribution, you could say, hey, the bar associated with the female group is a little bit taller at 54% than the bar for the male group, which is at 46. And you can just see side by side. And once again, by default, a lot of these programs put things in alphabetical order. You can put them in whatever order you really wanted. You could put the male bar first if you wanted. It's just the software that we had that did this happened to put in alphabetical order. So conditional distribution. So these ones are a little bit trickier. So it's saying, hey, focusing on, a particular value of a variable, what proportion of a second variable am I seeing? So it describes the values of one variable among individuals characterized within another variable. That's a little goofy looking. We'll explain what we mean with an example. So you're going to select a row or a column and focus on that, really. So we're not focusing on the total column or the total row now. We're focusing on one of the rows within the table that aren't the totals. And so we can use the data in the two-way table to calculate conditional distributions. And we can get a side-by-side graph. So we can do a bar plot, like a side-by-side bar plot that has grouping for each group. And it's easier to show than explain, so we will do that. So same example here. We're going to focus on the sex and the pet preference. And now we're going to look at the distribution of pet preference conditioned on sex. So focusing on female individuals here, there are 54 individuals. How many of those prefer dogs? There was 22 of them. This is not mental math for me anymore. I have to double check. I think I have like something like 40 point. You could round in a slightly different places for me, but 74%. There were 26 of the female individuals out of 54 of them. So 48.15% of the female individuals preferred cats. And then 6 out of the 54. So I'm conditioning on sex. So that means I am using these numbers here as my denominators. So when I'm looking at female individuals, I'm using this total, the total number of females. When I'm looking at males, I'm going to use 46 as my denominator. It's 11.11%. If I were to add those percentages back up, they should get to 100%. That's a good way to check. So then if I'm focusing just on the male individuals, there were 46 of them. And out of those 46, 36 of them said they preferred dogs. So that is going to be 78.26%. 8 out of 46 men there said that they preferred cats. I kind of feel like it would be higher based on people I know, but what do I know? 2 out of 46 is 4.35% had no preference. So when we're conditioned on sex, so if you're saying, hey, just looking at women, what's the breakdown of preference? So 48.74% of women prefer dogs, 48.15% of them prefer cats, and 11.11% of them have no preference at all. You can do the same for men. So that's our focus there. So if we want to go ahead and look here, this was the no preference. This is the prefers cats, dogs. And these are in percents, I believe. No preference, cats, dogs. And what's cool looking at this side by side is the female group. You can look, no preference is definitely the smallest group. Cats is the largest, but not by a lot. Dogs is kind of high up there too. But if you look at the male group, no preference is really, really small. Cats is actually pretty small. And then dogs bar is pretty high. So you can see that the preferences are not distributed the same between the two groups, between men and women here in this example. Similarly, you could have broken it down by preference. So you could have said, okay, well, looking at all the people that prefer dogs, what percentage of the people that prefer dogs are men? What percentage of the people that prefer dogs are female? That kind of thing. So if you look here, no preference. So this greenish color is female, and this, maroonish color, I'm not great with describing all of my colors sometimes, is male. So you can see that more females than males had no preference, but not necessarily a lot. Then when you look at preferring cats, a lot more, a much higher proportion of females preferred cats than men. And then if you look at dogs, it looks like it was actually males prefer dogs much higher than females prefer dogs. So it's absolutely very handy to have these side by side, because you can see that either way you look at it, if you look at it by sex, the preferences for pets doesn't stay the same between the two sexes. And then if you look at just each preference, the breakdown of sex is not the same either. That can be handy. So one issue or potential issue that we kind of comes up, it's not really a problem so much as something we should know about, is something called Simpson's paradox. So we're going to kind of summarize what it is exactly towards the end, but we're going to have it's a really common example that we introduce this to. And sorry, once again, binary sex here. We have men and women, and we're looking at a college in particular. And so they applied to this college. Some were accepted, some were not accepted. We're ignoring the waitlisted bit. And based just on what we see here, we saw 198 men out of 360 men accepted, which is 55%. So 55% of men that applied at this college at this time were accepted. 162 out of 360, which is 45%, were not accepted. Then if you focus on women, 88 out of 200 were accepted. So that's going to be 44%. 112 out of 200 were not accepted. That's 56%. So looking just at this, it looks like a much higher percentage of men were accepted, or 11% more men were accepted than women applying to this college. And although it's worth noting, 360 versus 200, a lot more men are applying as well. Almost twice as many men applied. So we want to get to this question of, is there evidence of discrimination? Are they accepting few women at a lower rate? Because if you just look at it like this, a much higher percentage of men were accepted. So we're going to break it down. We're going to break it down by two schools that they applied to. So we had folks applying to art school and business school. Most colleges have much more than just those two. Goodness knows we have quite a handful at OSU. But we're just going to stick with art school and business school here. So looking at art school, 180 men out of 240 men that applied were accepted. So that's 75%. And then we had 60 out of 240 men that applied were not accepted, or 25% of men. So 75% of the men that applied to art school were accepted. 25% of the men that applied to art school were not accepted. Then women, 64 out of 80 that applied to art school were accepted. So that's 80%. And then we had 16 out of 80 women that applied were not accepted, so that's 20%. So looks like maybe a higher percentage of women that applied to art school got accepted, although I would argue a lot fewer women did apply. Then looking here, looks like 18 men out of 120 applicants were accepted. That is 15%. That's pretty low. To be fair, I mean, certain schools have very different acceptance rates. So then I had 102 out of 120 applicants. that weren't accepted. So that was 85% of the men that applied to business school weren't accepted. Then I had 24 out of 120 women that were accepted. That's 20%. And then 96 out of 120. So I had 80% of women that applied to business school were not accepted. So if you look at it, these two tables, it looks like in art school, a higher percentage of women were accepted than men. And when you look at business school, it looks like a higher percentage of women were accepted than men, which is weird, right? Because overall we said, hey, a higher percentage of men are accepted to the college overall. So that's what the Simpsons paradox is. So it's that there's a lurking variable there. The applications were split between the business school and the art school. You can see that a lot more people applied to the art school. And then, I want to say the art school had higher acceptance rates. So absolutely, that had a huge impact there. So within each individual school, so within art school and within business school, a higher percentage of women were accepted than the men. I wouldn't say that based on this alone, you have a case that the school is discriminating against women in this scenario. Although there's definitely there are things to say about the fact that a lot fewer women are applying. Although that's not strictly discrimination. So this is an example of Simpson's paradox. So when you ignore the second variable, like which college, either business college or art college, the data suggests that women are accepted at a lower rate. However, when you do include it reverses the trend. You actually see a higher percentage of women accepted in both schools. So it's really, really interesting because when you include the type of school, that association is totally reversed. So that is going to be it for this lesson. I look forward to talking with y'all on the discussion boards.